Okay, so here's where I basically left off on the last video on primary hemostasis. We had fibrinogen coming out of the alpha granules and von Willebrand factor binding to the subendothelial collagen. We also had release of factor VIII and lots of other stuff that I mentioned in the last video. So that's primary hemostasis, but what happens next? So we're going to use this factor VIII. We're going to use our fibrinogen. And let's see what happens next. Here's how I think about it. So as far as the coagulation cascade goes, you want to remember that 10 to 10A is super important. That's where the extrinsic and intrinsic come together. And remember, this was from our primary platelet blood. So if you ever having a hard time on the exam, I just memorized these 12, 11, 9, 8. Why did I skip 10? Because 10 is in here in the middle, right? That's your intrinsic pathway. Makes sense. 12A is going to cause 11 to go to 11A, so on and so forth. What about our extrinsic pathway? Tissue factor, don't forget that. 7 to 7A uses proteases as well. 7A, 9A, as well as 8A with 9A come together and cause 10 to turn into 10A. I put 5A down here. Remember, 10 divided by 2 is 5. This is important for the next step. So what might the next step be? Right, you want to go 2 to 2A. This is your prothrombin to thrombin. This clump right here, this kind of clumps together and activates your thrombin. What happens next? Fibrinogen to fibrin. Just remember, when your fibrin is creating from a monomer to a polymer, 13A helps out. So visualizing these numbers is really helpful. And that's the way you get questions right on the exam. I'll keep going though. So another big concept is breaking down the fibrin mesh that is already there. And once you have your fibrin polymer and it's cross-linked, you actually, in pathologies, you want to make sure you can actually break this down. And if you have D-dimers present, we classically know this as being present in things like pulmonary embolisms, right? So if you have too much D-dimer, that means that this fibrin mesh is breaking down too much. Some extra notes. I know this is like a jam-packed page. I'll start here. So the star, anything starred requires calcium and phospholipid. So here, 7A, 5A, this whole reaction right here from prothrombin to thrombin, and your 9A. Interestingly, over here, actually, let me start here. So plasminogen to plasmin, you're going to have plasmin also activating your complement cascade. And for kallikrein is really interesting because not only does that activate the intrinsic pathway, but it also kind of auto-regulates. So once you have intrinsic pathway working, it'll come back and inhibit itself. Kallikrein also causes high molecular weight kallikrein to turn into bradykinin, and that causes dilation, permeability, and pain. Here you can see I put in pink. I'll start with thrombin because that's the one that's mostly in the middle. Has 5 different things that it upregulates. So it comes up and positively regulates 8 and 11. Thrombin also causes 5 to 5A. And of course 13. This one's the one that's kind of like an outlier, and it's like what's regulating it? Well, it's the thrombin. Here are some of the pathologies in red. C, hemophilia C, B, and A. Remember, these are X-linked. What about some of the drugs that we use for the coagulation pathway? Well, I'll start over here. So 10A anticoagulants are going to be your heparin, 10A inhibitors, of course, apixaban and fondaparinol. The 2A anticoagulants are going to be, again, heparin, and your direct thrombin inhibitors, right? That's why they're called that. Iatrogban, bivalirudin, and dabigatran. And just a quick note here, just notice how this has an XA in it, direct XA inhibitors, right? I found that pretty useful. Fondaparinol is an exception, but a lot of the ones that have XA are going to go ahead and be 10A inhibitors. Warfarin, you gotta know these numbers. In fact, this is why we go ahead and follow the PTT and not the PT. If you're doing heparin, you want to follow PT because it's over here on the extrinsic. And if you are following the sorry, I just totally messed that up. So heparin, you're going to want to follow the intrinsic pathway, which is going to be PTT monitoring, right? And over here, you're going to have PT monitoring. And also know that warfarin blocks all of these listed here, so that's why it's going to affect a broader range. As far as once you have your fibrin mesh created, you're going to want to start considering plasminogen TPA plasmin modulation, right? So if you're trying to break down the thrombus, you're going to use these. If you're trying to avoid the thrombus to break down, or say you had too much, say the patient responded poorly to thrombolytics, you're going to start thinking of antithrombolytics, that sort of thing. Those are some of the treatments. Okay, so here is again just a recap of all the pathways and modulations of each factor there. And you know what? I just realized these are mixed up. So I will go ahead and go back and fix that. But for now, just keep that in mind.